Okay, hello friends, good morning. Good morning to everyone.
Good
Good
morning, sir.
morning, sir.
Good morning. Okay, let's start with the discussion of today, and we are going to discuss some very important topics in cloud today. So before I'm going to start with the discussion, I want to ask you: is there anyone has any doubt regarding the previous classes? Okay, let me just remind you what are the topics we have already covered in cloud. From starting to the basics of cloud, we have covered the basics features of the cloud, then why we require cloud computing in real life applications, and then the essential characteristic of cloud. We have explained each and every characteristics individually, and then I have in the last class I have shown the differences between the cloud computing and its predecessor computing like grid computing, and then difference between cloud computing and utility computing. Why cloud computing is you can say better in terms of IT industry to support IT industry, IT resource services compared to grid computing or utility computing. That differences, the similarity we have discussed in detail in the last classes. Then in the last class I discussed about the cloud architecture, the general cloud architectures. It has two type of models: delivery models and deployment models. Within delivery model, there is a SaaS, PaaS, and IaaS. We have discussed each and individual model very detail. And in deployment model, there are four types of model: private cloud, community cloud, public cloud, and hybrid cloud. We have discussed each and every cloud with some suitable diagrams. Okay, so these are the things we have discussed with some real life example as well as some demo example in my previous classes. So is there anyone has any doubt regarding the discussions of previous classes? If you don't have any doubt, then we can move forward. Please respond. If anyone has any doubt regarding the previous classes.
Sir, it is clear, sir.
Okay, okay. Okay, very good. Then it is very fine. So we will move to the next topic, the today's discussion topic. Today, my main focus is to discuss one of the core technology that running behind the cloud computing, or you can say the heart of cloud computing services is called virtualization. That we are going to discuss today in detail. We are going to discuss the virtualization, the types of virtualization, why we require virtualizations, and how we can implement virtualization in cloud. But before we are going to start with the virtualization, I want to discuss some leftover topics regarding the you can say the module one of the cloud computing, basics of cloud computing. So that's why I want to discuss some leftover topics, that entities of delivery models. What are the various entities of delivery models that I think in the last class I already given overview of entities of delivery models. So in the cloud architecture, in the last class I have shown a bigger cloud architecture. In that cloud architecture, what are the components are there? I think you remember the cloud architecture which I already shown in the last class. This is the cloud architecture which I already shown in the last class. This one, the cloud reference architecture. So in this architecture, I already told there are several entities or several components based on which an entire cloud computing system made of. Okay, so there are cloud consumer, cloud auditor, cloud broker, cloud service provider, and cloud carrier. So these are called entities. So total 1, 2, 3, 4, and 5. Total 5 entities exist in a cloud. So among these entities, the first entity is the service consumer. You can say the end users who are using the facilities of the cloud computing platforms, or services of the cloud computing platforms. So this end user actually maintains a business relationship with and uses the services from service provider. So before the consumer can be an organization, or it can be an individual person. Okay, if an organization is using a particular cloud services, obviously the subscription rates are different based on the organization, because in the organization there are several person can handle the cloud. So based on that, the rate has been the subscriber has rate has been decided by the cloud service provider. So the service consumer is such an entity which actually handles the services or use the services provided by the cloud service provider. Okay, and it makes a business relationship with the cloud service provider. So they make a contract with the cloud service provider. It may be Amazon AWS, or it may be Microsoft cloud services, or it may be IBM cloud services, or Google cloud services. So they make a contract based on their subscription rate. They have to agree with the subscription rate, and based on the contract, they are using capable of using the cloud services, right? Second one is the cloud service provider, which actually provides the services available to the customer. So the cloud service provider's main job is to available the services to the customer at his best instant. Uh, uh, that means the service provider always try to give the cloud services to the service consumer by maintaining the quality of the services, okay, as well as the security of the service. I mean, the maintaining all the features. The cloud service provider provides the services to the end users or service consumer. It is the responsibility of cloud service provider of managing that services. Okay, otherwise, as a service consumer, if you are not satisfied with the services of the cloud service provider, then you will migrate from one cloud platform to another cloud platform. So that is the loss of their businesses. So that is the sole responsibility of the service provider to maintain a suitable relationship, a perfect relationship between the service consumer and the provider. Okay. Next one is the carrier. Carrier is actually an intermediary, or which are connected all the other four components or all the other four entities. Okay, so carrier is in this figure, it is very clear the carrier is a common entity which connected all these four components. Okay, cloud broker, cloud provider, cloud consumer, and cloud auditor, which carry information, which carry relationship, which carries some transport type of services between the provider and consumer, is known as the carrier. Okay, so within carrier, there may be a network cables, network wires, which actually responsible for carry information from one end to another, and from one entity to another entity. So these are the role of the carriers. Now the broker. So just like the broker, that this term is very common for everyone, familiar for everyone. When we are trying to purchasing a particular plot, or we are trying to purchasing a house or flat, we actually used to take the help of the broker. The broker, the main responsibility of the broker is to maintain a relationship or to contact you with the service provider. That means the flat owner who wants to sell his or her flat, and the consumer who wants to purchase the flat. So broker will take some sort of charges based on that, maintaining the relationship between the flat owner and the flat purchaser. So here in cloud system, broker play the same role. It is actually used to manage the relationship, negotiate the relationship between service provider and consumer. So suppose Amazon AWS has a set of brokers. So that the role, or the job of the broker of the Amazon AWS to show the advantage of Amazon AWS, and it will show how much it is benefited to use the Amazon AWS over the other cloud platforms. Okay, so if you are a consumer, if you are searching for a cloud platform to subscribe, the responsibility of a broker to fetch you from their own cloud service platform, okay, to show you, to boost up you with various facilities, with various benefits of that particular cloud service platform for which the broker is working. Okay, so it actually negotiates the relationship between the consumer and the cloud service providers, okay, or cloud service platform, whatever you say. That is the job of the broker. Last entity is the auditor. So in auditor is nothing but a third party. Please remember, auditor, a broker can be anyone, okay, which has a relationship with that cloud service platform. So it may be any person of the Amazon, suppose Amazon AWS service. So it may be any person, a trustworthy person of the Amazon AWS. So he or she can be a broker, okay, or any other third party which has some business relationship with Amazon AWS, they can make them broker. Okay, but auditor, you and me cannot be an auditor. A general person, a general third party cannot be an auditor. Auditor are very secure entity. That means not secure. You can say very authenticate entity. That means there are some authenticate auditor party or third party throughout the world, one or two authenticate auditor party who is taking the responsibility of this auditorship or assessmentship. The main job of the auditor is to assess the cloud services. Okay, that whether the performance of the cloud services is good, is suitable for the end user, for the customers, whether the cloud services provide a proper security to the for the cloud implementation to the consumer. Okay, and whether all these things will be assessed properly assessed by the auditor. And this auditor can be must be a authenticate person or authenticate group, third party throughout the world. That means it is independent. It has no influence by the cloud service provider as well as by the consumer. It is independent, just like the umpire, just like the umpire in a cricket, or referee in a football ground. It has no influence of the two teams. So in the same way, the auditor will take has no influence on cloud service provider as well as consumer, and it will take independent judgment, independent decision, or independent assessment whether the cloud service is good or not, or whether the cloud service provides proper performance, or proper gives proper services to the consumer or not, and with a proper security or not. Okay, because security is one of the major concern for the consumer. If the security has been compromised during the service of a cloud service provider, then the auditor will warn that particular platform to upgrade their security. Otherwise, the license of cloud service providing will be cancelled, okay, by the auditor. In the same way, that in our college or institution, there is a team which are coming to assess the quality of the teaching in the institution, like NBA team, NAC team. All you are familiar with this name, National Accreditation Board. Okay, National Board of Accreditation. So these sort of teams are coming, which are nothing but a group of people are coming, and they are actually expert in the team to assess that whether the college will provide a proper infrastructure to the students or not, whether college will provide the proper quality faculty strength to the students or not, whether college will provide the other facilities, the lab facilities, library facilities to the students or not. These are the individual assessment parameters has been given by the accreditation board, and the college will has to maintain those parameters to get the accreditation. Otherwise, the accreditation board will give a negative impact on the college, and based on that impact, the college will face some problems. Okay, so auditor also has a list of established criteria. Okay, initial list of established criteria, and before a cloud platform, a cloud service provider launch its platform for the business, for the business making perspective in the market. So that cloud platform must maintain those list of established criteria, and the auditor's job is to roll out each and every year to check whether that cloud service platform who are doing business in the market, they are actually following those set of list of established criteria or not. If they are not following, then they will give a negative impact. In sometimes they will fetch the license, or they will cancel the license of the cloud service provider to do a business in the market. Okay, so these are the major roles of the entities. These are five major entities, and they are the five major roles. So is anyone has any problem to understand what are the roles of the entities here? All the five entities roles and responsibilities is okay for you? Is anyone has any doubt? You can ask me. Is anyone has any doubt regarding roles and responsibility of entities? Please respond.
No, sir, no.
Is it clear to everyone? Is it clear to everyone?
Yes,
Yes,
sir. It's
sir.
clear.
Okay, so we will move on. Okay, so these are the benefits of cloud computing, which I already discussed in multiple times, like no upfront investment, lowering operating cost. Okay, operation cost is lower. There is on-demand service, pay-as-you-go service. So there is no upfront investment. That means you don't need to purchase the hardware for your own company or for your own using. Instead of that, you can just hire or rent the hardware from the cloud platform. So no upfront investment. Operating cost is low. Then highly scalable. Highly scalable means based on the on-demand services, the resources can be increased, the request resources can be increased, and it can be decreased as well. It is called scalability. Okay, it has some different sort of scalability. I will discuss the scalability in my later lectures, like horizontal scalability, vertical scalability, how this scalability is working. So it was one of the important topics, scalability and load balancing in cloud platform. Okay, next one is the easy access. Obviously, it is a web-based, internet-based access, so it is very easy. So you don't need too many in infrastructure to handle a cloud computing platform. You just need a simple machine and a proper fast internet connection to handle a cloud computing, but to use the services of the cloud computing platform. Last one is reduce the business risk and maintenance expenses. Obviously, there is no upfront investment and no hardware infrastructure. When it means a physical infrastructure you are using, so that obviously the maintenance expenses is less because the maintenance headache has been taken by the cloud service provider for you. You don't need to take maintenance headache by yourself. Okay, so obviously expenses will low. So these are the benefits of cloud computing, and these are the challenges. In challenges, I already discussed about security. Security is one of the very interesting, very important challenges where in research and development part is working to overcome the problems of security. But unfortunately, security is a very sensitive issue in cloud. Okay, till now security cannot be compromised or cannot be removed entirely from the cloud. So security is one of the important issues. Cannot build establish the security entirely in the cloud. Okay, there is an issue of security like malware attack or some sort of infectious or infected codes has been corrupted the entire system. So these sort of problems are very frequent in cloud system. Now difficult to migrate vendor lock-in. This problem I already discussed. So when you are locked in with a particular cloud service provider or vendor for a particular period of contract, so this is very difficult for you, for a consumer or customer, to migrate or to change from one vendor to another vendor within that contract period. Then you will have to face lots of issues, lots of ethical issues, lots of challenges, as well as you have to facing some sort of monetary laws as well. Okay. Now internet dependency, obviously the total cloud service issues that depends on the high speed internet. If you are staying in such a place where the internet is an issue, then in that case the performance of the internet is an issue. In that case it will be difficult for a consumer to handle the cloud computing services. Okay, so this is one of the challenges of cloud computing. Infrastructure failure. In the last class I already told the cloud computings are generally stored this sort of data center. This is an example of a Google Cloud data center. So cloud computing stored this sort of huge, mega data centers as a centralized data center. In last class, I already told the cloud follows a centralized and homogeneous sort of data centers, whereas the grid computing follows a distributed and heterogeneous type of data center. So centralized means if they suppose there is any natural calamity occurs, or if there is any sort of disaster occurs and this center has been destroyed fully, or most of the portion of the center has been destroyed, so it will make an impact to the entire cloud services of the Google throughout the world. Okay, because the data centers is a unique, and the resources are actually provided, the hardware or software, whatever resources is actually stored here, the pool of resources is working here, and it is provided through worldwide based on the demand of the customers of the cloud services. So obviously if it is a infrastructure, this infrastructure will fail, then it is difficult for handling those resources, or those provide those services. Okay, so this is an infrastructure failure. So in case of distributed system like grid computing, the infrastructure failure risk is less. Okay, less fault tolerance. Last one is data transfer bottlenecks. Data transfer bottlenecks, I will discuss this point individually. This point has been repeated twice, sorry. So data transfer bottlenecks I will discuss in the future classes, where there is a problem of transferring data. So there is an issue of by handling the high volume of data. Okay, because internet has a limited bandwidth, so based on that bandwidth you have to transfer the high volume of data. So suppose at a particular time multiple users throughout the world are giving request to or giving demand for a huge amount of resources. So that resources should be passed through internet bandwidth, internet services. So this sort of problems of data transferring, of huge volume of data transferring, is facing very frequently by the cloud services or cloud computing platforms. Okay. So these are the various data centers, centralized mega data centers, or you can say the data warehouses, where the resources, pool of resources has been stored, has been installed, and this is the internal structure of the data warehouses. The cloud computing platforms are working here. These are some examples I have shown you. Okay, from various cloud services, cloud computing platform. What are the hardwares are generally using to provide those services? So this is the you can say a comparison among the four famous cloud services: Amazon, Microsoft, Google, and IBM. So based on that, which are the company launched in which year, and what are the special services they are providing to their customer. Okay, so these are the differences, or you can say the characteristic, important characteristic, key characteristic of these four famous cloud service providers. Okay. So this is all about the basics of cloud. Now we will move on our next lecture, which is called a virtualization. Okay, cloud resource virtualization is one of the very interesting and very important. You can expect a list of questions. Frequent questions are coming from this topic, like cloud resource virtualization, how to perform virtualization, why virtualization are using. So you can expect a lot of questions from this topic. So I am going to start this one. So before I'm going to start this one, is anyone has any questions up to the discussions right now? Whatever I have discussed today, is anyone has any question till now? Please respond. If anyone has any question, please respond. Hello? Anyone has any question? What I have discussed till now? Hello? Hello? Anyone has any question? Hello, students?
No, sir.
No question? কারো কোনো question আছে till now?
No, sir.
Okay, so let's move on with the new topic of cloud resource virtualization. I request everyone to listen this topic. This is one of the hard technique, or you can say it's one of the core technique of cloud computing system. So each and every cloud computing system must have a virtualization, because the virtualization gives the consumer the flavor of illusion of using a pool of resources, or a huge amount of resources without hampering the actual hardware resources. Okay, so this virtualization is a very important topic. So everyone, please focus the discussion of this topic. Give your focus on it. So what is virtualization? So Wikipedia says virtualization in computing is the creation of a virtual platform. Virtual is nothing but an illusion, I already told, rather than actual. So it is virtual version of something, such as hardware platform, operating system, a storage device, or network resources. So virtualization means an illusion has been created on these things. Like hardware platforms are there, so it will create an illusion of the hardware virtual platform. It will create an illusion of the operating system, and it will create an illusion of the storage device, network resources, and so on. So a customer which is sitting at the end of the cloud computing system, he or she is getting an illusion or abstraction that he or she is using a particular operating system. Suppose he or she is using an operating system, suppose Mac OS. Okay, another customer, he using the same cloud platform, and he or she using, suppose an OS, suppose Linux OS or Solaris. Okay, so they think that they are the only customer who are connected with that particular cloud services, and they're using that particular operating system, and they're using all the resources of the cloud services alone. Okay, so no two customers can make an impact of each other's services, and they don't know that whether there are how many customers are connected at a particular time with that cloud service provider throughout worldwide. Okay, so the thing is that there is a strong isolation, a strong abstraction is working between the customers who are connected with a particular cloud services. So that strong abstraction, virtualization, everything has been provided by the concept of this virtualization, the virtual platforms. Okay, so that platform has no physical existency while the customer are using that platform in virtual form. Okay, but at the end, at the lower layer, at the bottom layer, there is a physical storages. I'm going to show you what is a virtual platform. So let me remind you, this concept is not new to use. Virtualization concept you have already used multiple times. In even you have already learned in the operating system the concept of virtual memory. Okay, so can anyone tell me what is virtual memory? Can anyone give me the answer? What is virtual memory? What is the use of virtual memory in operating system? You already read it. Okay, if the link is the session is going out, please click on the same link, join the same link. Okay, can anyone tell me what is virtual memory in operating system? In the memory management, you have already learned virtual memory. Can anyone tell me?
Sir, it is a memory management capability which uses hardware and software. to allow a computer to compensate for physical memory shortage.
Physical memory storage. Can you explain in more detail form? In more detail.
It temporarily transfers data from RAM to the disk storage.
So virtual memory takes the help of physically which storage it will take the help. The virtual memory is actually a logical concept. It's not a physical concept, right? But a virtual concept. So there must be some memory which actually giving help to implement that logical concept. What is the name of that memory? From where the virtual memory gets the actual memory to store the data? That's what I'm asking. What is the name of that memory? এক্ষুনি তো বললে বলো।
Sir, RAM.
Not RAM. RAM is a problem. RAM is actually a problem. Based on that, the virtual memory comes into a picture to solve the problem of RAM. But there must be some memory which is working as a base memory behind the virtual memory, which provides the actual memory to store that extra data that is not fitted into RAM or primary memory. What is that memory? কে তোমার ওই বেস আর্কিটেকচারটা প্রোভাইড করে? ভার্চুয়াল মেমোরি। অ্যাকচুয়ালি ব্যাক এন্ডে কোন মেমোরিটা কাজ করে? দ্যাট ইজ আই এম আস্কিং। তোমরা জানো, বলো। You know the answer. The memory is secondary memory. Okay, your hard disk drive, which will working like a virtual memory. So virtual memory is a virtual concept, it's a logical concept. It doesn't have any physical existence. So it will take the help of the hard disk drive or secondary memory to provide the storage of the extra data which is not fitted for a particular amount of time, which is not fitted into the primary memory. Suppose the data will be used in future by the processor, so the data will be transferred to the virtual memory, which is nothing but a secondary memory or hard disk drive, and data has been stored there. And while there is a demand of that particular data for the processing, then the data will be again transferred back from the virtual memory, or you can say the hard disk drive, into the main memory, and from main memory to the processor. Okay, and this entire scheme has been managed by a special memory unit which is called MMU, Memory Management Unit. You are already familiar with this term, MMU, Memory Management Unit. So this is one of the example of virtualization that we have already used. We have already know that is the implementation of the virtual memory. Another example is the CPU sharing in multi-programming. This multi-programming and CPU sharing, same concept. That means multiple processes are running on the same CPU on a single CPU platform. That means they are actually sharing the processing power of a single CPU. That is the CPU sharing, because you have used the CPU sharing in case of multi-programming concept. Multi-programming you have already learned in the operating system. So these two are the concept of the virtualization you have already used in operating system. So in cloud computing perspective, this virtualization concept is not new for you. Okay, so it is a little bit different. So before I am going to show you how the virtualization works in cloud computing, so let me show you what is the job of the virtualization. The main job of the virtualization is the resource management. Okay, for the resource management, we will use the virtualization concept in cloud computing, right? So what is resource management? So resource management is actually there is a wide range of customers who's actually working on different applications running under different operating system, and it is very difficult, it is a problematic issues to handle that situation, because the customers ranges are different. Customers are sitting in different places worldwide, geographically they are separated. They are joining schemes or joining policies are different. They are using hardware. Okay, they actually deploying their applications on different operating systems. Suppose one customer deploying the application in Mac OS, one customer deploying the application in Linux, another customer deploying the application in Windows, and so on. So they are using different heterogeneous type of operating system, and it is very difficult for a cloud computing platform to handle those resources. Okay, so virtualization actually helps to handle this sort of resource management issues. Not only these issues, this is the only problem, but also the problem becomes much worse when the users are uncooperative in nature, and when the users are oversubscribed. That means you are taking money, but you are from the user, but you cannot provide the services, proper services to the user. Obviously the users are uncooperative and they make a case against you. You can file a case against you. Okay, So these sort of problems are increasing. It becomes becoming worse when the resource management, you cannot handle the users, or users are more uncooperative. So in addition to external factor, there is some internal factor as well. Internal factor means there is some heterogeneity of the hardware and software system. Various kinds of hardware and software system users are demanding, and they want to use, and it is a difficult for a single platform to handle that heterogeneity, that the differentiality, the versatility, you can say the differentiality or heterogeneity of the hardware and software system, and and it is difficult for the cloud system to provide to accept those heterogeneity, and redistribute the load and reduce the failure rate of the different components. So these are the factors why virtualization comes into the picture. Virtualization resolves this issue, try to resolve these issues. Okay, now the alternative solution or alternative resource solution is resource virtualization, which I already told you. Now, why we require virtualization? These are the 5 points why we require the virtualization. First point, to reduce real estate needs, then increase uptime. Okay, so the services, time related services or timing services will be provided. Okay, so based on time, a particular service will be provided with the help of virtualization. Then reduce carbon dioxide emissions, CO2 emissions, power and cooling requirements. Obviously, you can understand while we are using virtualization, the user, then you doesn't need to provide to the user a physical platform, a physical resources, right? Instead of that, the user takes the help of virtualization. You are creating a virtualized platform in front of the user, and user can use that platform and can seems to be that he is using the actual physical resources. Okay, it is working like abstraction or illusion. Okay, so when the cloud computing cloud service provider doesn't provide a physical platform, obviously it requires less power, less electricity. When less power, less electricity consumption occurs, obviously carbon dioxide emission will reduce. Okay, because it depends on the power dispatches or electricity dispatches. So one famous statement tells that if one bit of information is lost, then it will emit 1 kilojoule of heat of each against one bit of information. So you can understand how much heat hardware will generate for losing of one bit of information. So this is the things, and obviously when you require less power, less electricity, obviously you require less cooling arrangement. Okay, you don't require an air condition arrangement. Now it will increase the flexibility of the virtualization. Obviously multiple users can connect to a single cloud platform in a geographically separated areas, from a geographically separated area. So it will actually increase the flexibility. Okay, on demand service scalability, it will increase. Now reduce the overall cost. Obviously it doesn't require a hardware support, so obviously it will reduce the overall expenses of purchasing that hardware. So instead of that, virtualization provides that virtualized flavor to the user, right? Now the difference between multi-programming and virtualization, what is the difference between them? Very simple. In multi-programming, CPU is shared among processes, but in virtualization, CPU is shared among operating systems. So I already told one user using macOS, another user using Windows, but the underlying processor is same, which actually handles or create different virtual platforms for different operating systems. So CPU is shared among those several OSs. Here the memory is shared using page table, but in virtualization, obviously I told you that each and every user uses different operating system. So each and every operating system, virtual operating system, has its own virtualized page table. So multiple page tables is there, and there is taking the role, there is a role of the virtualization to handle these multiple page tables into a single page table. Okay, the last one is process node. This is being managed uses system calls, and in multi-programming, system calls, various system calls you are already familiar with to handle the multi-programming. And in virtualization, it is being managed by OS itself. OS may or may not know how that is it is being managed. Okay, so there is no responsibility of the OS. Okay, so this is a diagram of between the traditional server and the virtual server. This is the server where the virtualization is not affected, is not implied.